Okay, let's take a little bit of time and let's look at our second unit where we're going to start talking about functions. To start with, we have to be able to distinguish between relations and functions. Um, the way we need to think about this is if you think about the fact that relations is just the set of all things that show a relationship between two variables. There's just some kind of relationship that is a relation. Okay, so we've got that part, and that's just about anything you can draw in a graph, make a mapping, table of data. You have so many things that are relations. But then there's a subset of that comes in, and that subset are functions. And functions are special in the fact that all of the input values will be different. So all input values are different. Doesn't really fit in the spot, but you get what I'm saying. So there we go. So we're going to distinguish between the two. So functions are a subset of relations. So whenever we come up here and we're looking at this question, it says how many different ways can you represent the information in this table? This, we know it's a relation because there's a relationship between the items on the left and the items on the right. Okay, so we have x values and we have y values. So we know -2 goes with 5, 1 goes with -3, 0 goes with 4, and 3 goes with 2. So they're mated, they're paired. So how many different ways can you do that? Obviously a table. Well, there's some other ways that we can do this. We could write them as ordered pairs, as seen in this first column right here. So ordered pairs would work where you put parentheses around each. And these are using different numbers, but same idea. There is something called a mapping where you'll have a blob. It doesn't have to be this rectangle, but basically you just have this grouping of all of your input values. And you have a grouping of all your output values or your y values, and there will be arrows showing the relationship. And it's very important that you see that the arrows only exist on the right side. It does not go the other direction. So it initiates on the left and ends on the right. So that shows you that 4 turns into 3, or 4 is matched with -1. It does both. And then you can see where 3 results in a -1. And -3 results in a 4. So we could write that as ordered pairs, just as they have right there. Then we have the table version, which we saw at the beginning. And then you have the fact that you could plot all of these points. Now we're not going to connect them. Nobody told us that it connects to form a line or anything like that. So all we know for certain is that these are ordered pairs. So we could go in and we could plot all these ordered pairs, all 4 of them. So there's a variation of the way that you can actually show relationships in data. You can do ordered pairs, mappings, tables, and graphs. Okay, well, let's dig a little deeper. So we also want to talk about what a domain is of a function. Okay, now we swapped over to the function word. So let's actually come down here for a function. Remember what we said earlier, all of the input values, and that would be the x values, are different. Okay, so I didn't say anything about the y's, so the y value or the output value could be the same, but the input values must be different. So now we're going to come up here and we're going to answer this question about domain. Well, domain values are all of the input values. So basically all your x's. For your range values are all of the output values, or your y. Okay, and when we list those, if we're ever asked what those values are, we're going to create a set of numbers. Sets are always written in braces. So we're going to use that, and you can see here there's a good demonstration right here. They have this example. So this it looks like a little curly Q. Those are braces. That tells you that this right here, this group of ordered pairs, is a set. You know that because of the braces are being used. Okay, now it actually goes through and says the exact same thing that we just said. Domain is a set of inputs, or your x coordinates. Range is a set of outputs, or your y coordinates. Then it goes on and it says, well, what are the domain and range of this relation? Well, typically we just do D for domain equals, and then we do want to use the set braces. So, and then let's list all of the x values. If we come up on something that repeats, we do not put it twice. We only list it once. So I have -3, 0, 2, and then I'm just looking in the beginning, the first number in each ordered pair. That is my domain values. When I have them all listed, I close my braces and I'm done with that set. So for range, I'll do an R, and I'm looking at the back of all the ordered pairs. So I would open my braces, and then I have a 14, 7, 0, -18, and a -99. So that is the range values there. Nothing repeated, but like I said, if it did, I would only write it one time. So let me go back here to an example. Like this group right here. If I wanted to give the domain, looking at these ordered pairs, my domain would be -3, 3, and then 4. I would not list the 4 twice. I would only put it in the set one time. Okay, so that just gives you an example of the way we would need to type it. Okay, so moving on, how do you distinguish whether or not it is a function? So it says a function is a relation in which each element of the domain corresponds with exactly one element of the range. Sometimes that's hard to understand. The easiest thing to think of is all of your x values have to be different, okay? They cannot be shared. Now, it's super easy to look at that and know what we're doing when we've got ordered pairs, because ordered pairs, you can come in here and you just see, okay, I got 4, 8, -1, 6, and there's 4. Well, that's a repetition. So since 4 repeated, this is not a function. It is only called a relation. Okay, because remember, functions are a subset of relations. So this one is not a function. And then again, we can come down here and do this other ordered pair, and you just check on the front, -7, 9, 14, and +7. Well, those are not the same. -7 and +7 are different. So this is a function. So we have not a function up here, so this is a relation only. And then this one is a function. Okay, so must have that behind something there. Same thing down here. Anyway, if you go over here to the mappings are a little bit trickier to see what's going on. Think about it. If you were going to write these as ordered pairs, this would be -3 matched with -2. 0 matches with 7, and 4 matches with 1. Basically, you want to make sure that each arrow, or each element of the domain only has one arrow originating from it, and this works. So this one is a function because there's only one arrow coming from each number. A contrast to that is look down here. 6 is good, 4 is good, 3 is good, but 2 has 2 arrows originating from it, which means we would have 2 -3, and we would also have 2 +3. So this fails. It is not a function. It is a relation. Okay. Now, if you're talking about a graph, it's so much easier to distinguish function or relation if we use something called the vertical line test. Now, the reason we want to do a vertical line test is because if the x value is the same, then the 2 dots, the 2 points, will basically be in a vertical line. So if this had been 3, 1, and this had been 3, 4, okay, we would be, think about it, we would be coming over to 3, and we would go up 1. I'm trying to make some parentheses there. And then we would come over to 3, and we would go up 4, which would make these 2 dots basically on top of each other. That only happens when these x values are the same. So if you can do a vertical line through any point of your graph, it is not a function. it is only a relation. So this is just a relation. So if you come down here and look at our examples, this vertical line, it hits 1, 2 times. And if it hits more, I mean, it's definitely not a function. So this is not a function, this is only a relation. It hits more than once. Now anywhere you draw a vertical line on this, it will only touch the graph 1 time. So this is a function. It never doubled up. On this one, if you just have dots, if there's a place where 2 dots double up on that vertical line, it fails and it is a relation only. So you can use a vertical line test with only points. Okay, so let's practice these and then we'll come back here in a little bit and talk about evaluating functions. So if you're going to use the vertical line test, now if I just drew it over here, yes, I would only hit once. But remember, if there's anywhere in the graph where it hits more than once, it fails. So hitting it anywhere inside the circle fails, and this is a relationship. Okay, so this one is fine, this one is fine, he's fine, he's fine. Looks like we're good. Every one of them, none of them are on top of the other. So this is a function. And this curve here, anywhere I want to draw a vertical line, I am not hitting it twice. I'm only hitting once. So that is a function. A lot of people call this the pencil test because you can hold your pencil vertically and just kind of scoot it across. And that will work just fine. Just make sure you're holding it vertically. Okay, y'all practice those and let me know if you have any trouble.